as an example here, you can go back to the data from this example, and you can compute S values. So you can compute S's instead of R's. And I'll tell you, for example, what some of these are. So sample 1, 2, 3, and I'm not going to write these all out, but sample standard deviations are like 1.82, 1.92, 1.82, the fourth one is 1.14. Let me come down here and tell you that number 15 is 2.35, number 16 is 5.63, number 17 is 2.88, and number 18, the sample standard deviation is 3.58. And you can check, for example, that a standards given upper control limit for S is going to be, well, what do I want? I want this number big B6 times sigma, and that means I want, if I look in the table on page 509, I want 1.964 times 1.715, and that turns out to be 3.37. If you try to compute not an upper control limit but a lower control limit for S, what you find is that there is no value big B5 table for a sample size of 5. So there is no lower control limit, and the reason is that the mean minus 3 standard deviations for S turns out to be negative, and it makes no sense to make a negative control limit for sample standard deviations. But my point is this: if I apply that number 3.37 to these values, so I didn't write them all out, but if I had written them all out and applied the 3.37 to all of those S's, what I find is up through sample 15, nobody plots outside of control limits. However, sample 16 has a standard deviation that exceeds that upper control limit for S values, and as a matter of fact, so does sample 18. And so if this upper control limit for S had been applied in real time, we would have seen evidence of process change at sample 16 and then again at sample 18. The point is that a standard deviation of 1.715 is just not tenable as a description of data collection across that whole period. If I wanted to make retrospective calculations, so you can check that if you add up the S's and you divide by the number of them, that is, you add them up and you divide by 18, as it turns out, what you get is 30.72 divided by 18. You get an average S of 1.72, and that means that a retrospective upper control limit for S is, well, what I need is a big B4 times S bar. Big B4 for a sample of size 5 turns out to be 2.089. And I multiply that by 1.72, that turns out to be 3.59. And if I go back and apply that to these sample standard deviations, I continue to see that sample 16 plots outside of that limit. So a retrospective upper control limit is this, and we still have evidence of process instability. In the Deming data, or the Deming drama data.